So if we have a function f of x, and we know this function has a derivative, you can take the derivative of that, differentiable. If f of x is differentiable, and if g sub x is the inverse of f of x, then g sub x also is differentiable. You can take the derivative of that. And we found out that the derivative of the inverse function, the derivative of that, somebody did the math for us, is equal to 1 over f prime of g sub x. An example. Let's assume, as an example, f of x is equal to 1/4 x to the third plus x minus 1. If I graph that, if I have a graphing calculator and I graph that, it will look something like this. Something like this. F of x. X cubed always looks that shape. Now you want to find the inverse of that. Graphically, you draw a line, y equals to x. There's my red line, y equals to x. And you flip that, and I don't have good imagination, but hopefully I can do it. It will look like this. That's the inverse of it. I have a horrible imagination. Here's the question. Question number 1. What's the derivative of x when x equals 3? Oh, that's not a big deal. When x equals 3, it's somewhere here. And I need to know what that slope is. That's what the derivative is. Can you tell me what the slope there? Well, let's take the derivative of that. F prime of x equals 3 times 1/4 is 3 over 4 what? X squared plus 1. What is the derivative at 3? 3 over 4 times 3 squared, which is 9, plus 1. 27 over 4 plus the 1. The 1 is 4 over 4. So what do we have? Is it 31 over 4? I could have made life easy on all of us. I could have said, what's the derivative at 2? The derivative at 2 will be what? 2 squared, 4 times 3/4, that's a 3, plus 1, which is 4. Much easier, the math. But no, I always take the fun path, the difficult one. But we can find the derivative at any point. Here's the fun part. What about the derivative of the inverse function. And I don't want to find the inverse function. One way of doing it is to find the inverse, then take the derivative of that. Remember how we find the inverse? I can find the inverse function. You say, well, how do you find the inverse of this? Let's say I ask you for the derivative. That's the inverse function at x equals 3, when x equals 3. Here's my option. One option, the long way. So option 1, I'm not a fan of it, is to find the inverse first. Then take the derivative. So to find the inverse, well, we go at f of x, we call it y equals what? 1/4 x cubed plus x minus 1. That's step number 1. Interchange x and y. And solve for y. That's how you find the inverse. Then you take the derivative of that. That's the long way of doing it. I can find the derivative without solving for y. What method can I use to find the derivative here? Why is this section directly after implicit differentiation? Because now I can use implicit differentiation to find the derivative of that, and that's the derivative of the inverse. So this will be what? Derivative x, that's 1. Derivative of that, 3/4 times y squared times dy dx, plus the derivative of y, which is 1 dy dx, minus the derivative of 1, which is 0. One equals 3/4 y squared plus 1 times dy dx. And to get dy dx is going to be 1 over 3/4 y squared plus 1. You tell me where you want to find the derivative, and I'll give you what the answer is. We want the derivative when x is 3. It says when x is 3. Well, I don't have even x in this one. What a pain. How can I find it? This one says I need y. So guess what? I gotta go to this one, let x be 3 so I can find y. So here we go. Y equals, the question was 1/4 x cubed plus x minus 1. When x is 3, did I ask for 2 or 3? Was it 2? 3, right? When x is 3, oh, the answer is, you mean 2? So 3 cubed, which is what? 27 plus 3 minus 1. 27/4 plus the 2.
I'll let Matthew do it.
That's 8 27 plus 8 is what? 35 over 4? That's... Then I gotta come back and plug it in. Take that number and plug it in, square it and plug it in, and see what that number is gonna equal to. And that's your derivative. You can see that's why I don't like this method. So what is option 2 then says? Instead of doing all this extra math, I got to find the inverse and all that. I don't have to find that. To answer this question, I'm going to show you option 2 now. The same question. Option 2. Again, option 2 says if you want to find the derivative of g at 3 here, we are asking at 3 is going to be 1 over f prime of g sub 3. We don't have g sub 3. Wait a minute. Let's see, how do we find g sub 3? Remember, g is the inverse of f. That's what g is. So can you tell me when is this guy, the y value of this, is going to be 3? Remember the inverse function, if I can find out what value makes this one 3, what x value? If we can solve for it, or if we take the derivative of that, so that will be 1 over f prime of the inverse function at 3. The inverse of f, that's what g is. What's my f of prime here at 3? What did I find for an answer? Oh, that's the derivative. Need the inverse. Sorry. So I need to find what g sub 3. I need to know which value, since that's the inverse of that. For example, when this is 3, if the y value is 2 here, or when this is 2, what do we have? What's that one? 2. That's 4. That's 1. That should have been, that's a minus. Isn't that a minus here? When x is 2? That's an error here. It's a minus. It's when x is 2. F prime, when it's 2, what do we have? That's 4, that's 3 actually. Yeah, 3 plus 1, which is 4. What is f? I did earlier, I asked for the function. No, I didn't ask for the function. I need to find out what's the value of this function, f of 3 itself. What's f of 3? Or f of 2? I can ask for it. I'm trying to find out what value will give me a 3 for an answer here. That's what I want to find. What value of x will give me a 3 here? So if I do a 2 here, would that give me a 3? When that's 2 here, what do we have? What's 2 cubed? 8. 8 divided by 4, that's a 2. 2 plus 2 minus 1, which is what? 3. When x is 2, the y value is 3. Why am I interested in that? Because the inverse function says when x is 3, then the y value is 2. Remember, the domain becomes the range becomes the domain. So if I know f of 2 gives me a value of 3, then I know what g sub 3 now is, and that's a 2, without finding the inverse. G is the inverse of this one. So I need to know what x value will give me a value of 3 here. It happens to be the 2. Now when we ask what is the inverse of g at 3, I go, oh, I got it now. I got to plug in 2 here into this one. And if you plug in 2, this is my f prime of x. What's the derivative at 2? 3/4 times 2 squared plus the 1, that's a 4, and that's a 4. Without having to find the inverse and take the derivative of that. All the stuff just going right through, just showing you what's going to happen here. What I'm interested in, it's the derivative of the inverse of sine, cosine, tangent, secant, cosecant, the inverse of them. So here's the important stuff. 6 properties, very important to us. One of them, the derivative. Now, some of you probably never heard the word arc. Arc means what? Inverse. If this is x, it will be x over, but because it's u sub prime, is going to be, u is going to be u sub prime over the square root of 1 minus u. The derivative of the cosine, or arc cosine. It's negative. The derivative of the tangent, or arc tangent. It's what? It's u sub prime over 1 plus u squared. The cotangent. That's a negative. These two similar, these two similar. That's one group. One group. We have one more group. Secant. Sine, cosine, tangent. Secant, we'll do the secant first. Again, that's the same as secant to the minus 1 of u, and this is positive u sub prime over absolute value of u, the square root of u squared minus 1. It's not often we use these in engineering. Once in a while we use them. This will be a negative so there's the other group. That's really what you have to know from this section. If you have an inverse function, these are the derivative of them. We had a problem we did early today on the first video. What was it? Video 1. Now you'll see how we're going to do that problem. And maybe about 30 seconds. It was this one. We did it this way. I mean, it wasn't that long to do it that way, implicit differentiation. But if you look at that, we'll see if we get the same answer. I'll come back to this sheet. The problem was sine y equals x. And we want the derivative y. One way to get rid of, I'll put it like this. One way to get rid of that, the sine, you take the inverse sine. So y equals the inverse sine of x. So if you want the derivative of that, using rule number 1 from today, using this one, this is your u right here, which is x. What's the derivative of x? So it's 1 over the square root of 1 minus x. I forgot to write squared on both of these. Make sure you put this squared there. All these have a squared in them. I forgot to write the square on that one. Let's see if that's the answer we got early. Is that what we got early when we did the math? 1 over square root of 1 minus x squared. Let's try another one. Cosine of y plus, or I'll go like this, y equals, I'll change my mind, I'll come back to this one. Y equals the inverse secant of x squared plus 3. Just to make sure you can do the derivative. What's the derivative of that? The inverse secant, I got to find the secant right here. So this piece here is your u. If you look at that, what's the derivative of u? 2x over the absolute value. I'm not going to put the absolute value. Why? I didn't put the absolute value.
Because it can never be negative.
Correct. Because this is squared and you're adding a 3 to it. This will never be negative, so I don't need the absolute value. U squared and that's my answer. That's it. just to practice these rules here. Y equals, I'm just taking examples, arc sine or inverse sine of 2x. What's the derivative of that? This is your u right there. So let's look at the sign. It says what? U sub prime over the square root of 1 minus u squared. What's the derivative of 2x? 2 over the square root of 1 minus, when you take 2x and square it, what are you going to have? Is it 4x squared? Done. Y equals the inverse sine, oh, not the inverse sine, let's pick something different. I'll do this inverse sine, or of the square root of x. Again, this is u. The derivative of that it's u sub prime over what? Square root of 1 minus u squared. So in the bottom, that's an easy one. 1 minus, when you take a square root and square it, what happened to the square root? Gone. But what's going to be on the top? What's the derivative of the square root of x?
1 over 2 times the square root of x.
Yes, because that's really x to the 1/2, right? So it's 1/2 x to what power? Negative 1/2, which is 1 over 2 the square root of x over you want to simplify that, that's over 1. Outside over the inside. Outside, inside. So when you simplify it, 1 times 1 is 1. 2 the square root of x times the square root of 1 minus x. Y equals secant, let's have fun, inverse secant of e to the 2x. Ooh. Inverse secant. Again, this is your u right there. According to our book, it's what? U sub prime over absolute value of u square root of 1, or I mean the u squared minus 1. What's the derivative of u? 2e to the 2x, very good. Over. Again, you don't need the absolute value because e to the 2x is always positive, even if x is a negative number. That's an exponential function. Exponential function looks like this. It never goes below the x-axis, so it never be negative. There's no need to put the absolute value. Square that one. When you square it, you multiply it by itself. When you multiply, what do you do with the exponent? You add them. So what's 2x plus 2x? That'll be e to the 4x minus the 1. So you're squaring e to the 2x. E to the 2x times e to the 2x is not e to the 4x squared. When you multiply, you keep the base and add the exponents. 2x and 2x is 4x's. The key to this section, the entire section, is these identities. That's the key. That's the whole section.
Can you simplify that last one?
To which way, Pat?
Not that. You just take out the e to 2x?
Here?
Yeah.
Can't because the minus 1.
Well, I meant leave the square root down there, but e to 2x on the top, and e to 2x on the bottom.
Oh, this one? Oh, yes. Oh, I see what you're saying. So e to the 2x here, can you cancel them out? Yes. So that would be 2 divided by e to the 4x minus 1. Absolutely yes. Good call. I thought you meant like fact, take it, yeah. Yeah, if you have matching stuff on the top and the bottom, just like any algebra, you can always cancel that. As I said before, memorizing these is the key, but if you remember the top one of each one, the bottom one is identical with the exception of the minus sign. All the ones that begins with the letter C, every one of them, it's always a minus.
We're gonna be quizzed on those 6, or?
You gotta make sure you know them. Sure.
All right, I'm okay with it. I'm ready.
All, plus the old ones too.
You put 6 on one?
Yes.